Hello all, welcome to Tech Capture. So in our previous video, we just had the small discussion about BigQuery, what is BigQuery, BigQuery architecture and introduction of the BigQuery. Now we are going to discuss about two very important concepts of BigQuery in this video, that is a BigQuery partitioning and BigQuery clustering. So if you are preparing for our data engineering interviews in Google Cloud, so this is our most common question asked in interviews, that what is our partitioning, why we need partitioning, how we can create partitioning, what is the benefits of partitioning. So all these questions will be asked around partitioning and clustering. So these are basically the questions around the performance of BigQuery, around the cost of the BigQuery. So we are going to discuss all the things about partitioning and clustering in this video. So first we'll see the conceptual view, why what is a partitioning, why we need partitioning, and what is the benefits of partitioning. And now after that we will go to the cloud console and we'll try to implement with a hands-on how we can implement the partitioning and how we can implement the clustering. Okay, so just stay tuned till the end and we'll learn with the hands-on what is a partitioning and clustering. So first we will see what is a partitioning. So partitioning is nothing but we divide a large table into small manageable parts based on the column. So it is used to improve the query performance and to reduce the cost. Now if we can see, let me just get the pen here. So what is a partitioning? So this is a important line here, that partitioning is dividing the large table into smaller table, which is a manageable part based on the column. So partitioning can be done on any column? No, partitioning can be based on these three types of column. It can be done on the date column, timestamp, or date time columns. Okay, so mainly these are, if there are any integer column, it can be done on the integer, or if there are no columns which is in this category, then there can be a ingestion time partitioning as well. So we'll see all these things when we do a partitioning. But what is the use case or what is the benefits of partitioning? So this improve the query performance and this will reduce the cost. So we will see in a practical way how it will improve the query performance and reducing cost in our demo. But the important things you have to remember for your understanding, that partitioning, it means dividing a big table into a smaller table. Let's say suppose I have 2 years of data in my one of BigQuery table. So what is partitioning? So instead of having 2 years of data in a very big table, I will just create partition of each day. So it will be remain the same table, but data will stored in the partition. It means the one day, my first day of data stored in one partitioning, then another day, the next day. So whenever I query the data, it will query only that particular day. It will not scan whole 2 years of data. That is how the partitioning will help here. Okay, and what are the benefits? The faster query, you can see here. One is faster query, lower cost, efficient data management, and best practice. So it will not give you benefits directly. To get this benefit, let's say suppose you are partitioning based on the date column, then you have to always use that date column in the filter condition. That is the important thing here. It doesn't mean that okay, you are using the partitioning but you are not using the query properly, then it does not give you a more benefits. So you have to follow the some best practices as well if you are using the partitioning. Okay, so that is about the partitioning. So if it is not clear, do not worry, we will see live demo how it affect the query performance, how we create the partition table, and how it reduce the cost as well. So we will see with the live demo. Before that we will see the clustering. The clustering is say, but instead of dividing table into the large column, it is just, I will just show you what is the clustering. Okay, so what clustering will do? So it organize data within the partition based on the specific column. So let's say suppose in my, I'll give you example. So let me just go to the next page. It will give you the clear idea. Okay, so now just take example here. Okay, so you will understand the difference between the partitioning and clustering. So take the first table, this table. So this is not partition, not cluster. Data is randomly put. Now this is the order data. Okay, so what is happening here? So you can see the data is randomly stored in the table. So you can see this is the 2nd August, 4th August, 5th August. Again this is 2nd August, 5th August, 4th August. So let's say I have to get any data between, like, let's say 6th of August. I want to get data on the 6th of August. So I have to scan whole table because my data is randomly split. Okay, so when I scan whole table, I will be charged based on the whole storage of this table, and time it will take to scan whole table is definitely more. Instead of that, what I can do, I can either cluster table and then partition. So what is mean by clustering? So I will just take the common value or frequently use the value from the column. Now let's say country. So your partitioning is based on the column, but your clustering based on the value of the column. Now just for time being, you can see this table. So this is cluster table. This is not partition, this is just clustered. So what we are doing, so we are just storing the data together. For the Japan data we are storing together, so this country we are storing together, for UK we are storing together, and for US we are storing together. So whenever I need a data for particular date for particular country, I can use the filter of country. So it will scan only this partition. Let's say suppose I want data for US, so it will scan only this partition. It will not cost us for this amount of data, it will cost only this amount of data, because our query will scan only this part of the data. Okay, but here if you want data of US, you can see US is here, US is here, so it is randomly stored in memory. So we have to scan whole table. It will take more time, and more data it is scanning, it means more cost, because BigQuery cost is how much data you scan, how much data you query. So this is about the clustering. Clustering is we are just grouping the data together, we are just storing the data based on the values. And what is partitioning? Partition, you can see we just create, now this was our one table, so now we create a small table. How we created? We created based on the date. So this is both partition and clustering. So we create one partition from 2nd August, we created one for 4th August, we created one for 5th August, we created one for 6th August. Now let's say I want data for 6th August. So I will query only this table. My data, my query will just fetch only this data, and I will only take time for this data and only cost for the this amount of data storage only. If no partitioning clustering, it will scan whole table. So again, if I am using partitioning and clustering, it will save my time as well as the cost. Now this is on the conceptual view. So how to implement that? Okay, so let's see how to implement that. Before that, I'll go back to slide. Hope you understood now. So partitioning and clustering. In partitioning, we partition based on the column, and in cluster we partition based on the value of that particular column. If there are, let's say if your data is having multiple country, you can cluster your data based on the country. If you have data considering multiple department, you can cluster your data based on the department. Okay, so it can be on the categorical value, but your partitioning is based on your only date or timestamp column. Okay, so I will just show you demo now how to create partition table. We will see three tables: first without partitioning and clustering, then with partitioning, and then with partitioning and clustering, and then we'll see the impact on the performance and the cost. Okay, so let me go to the Google Cloud Console now, and there I will try to create few tables. So I am in my BigQuery console, BigQuery Studio. So here for partitioning and clustering demo, we need a high amount of data, maybe in million records or in few GB of data. So it will give a better idea how partitioning and clustering works, because it used on the data where the data is very huge. So what I will do, I will just use one of the public data set. So you can see I have a public data set. I already shown in last video how to access the public data set. So here are a very huge tables are already publicly available. So I will just use the very well known example, that is Stack Overflow. So everyone knows the Stack Overflow. We post the questions on the Stack Overflow, and there are millions of questions on the Stack Overflow. So these are publicly available on the BigQuery. So I will just go to the Stack Overflow dataset, and I will show the data there, how much data we are having there, and we'll try to see the example of Stack Overflow data and the performance without partitioning and clustering and with the partitioning and clustering. Okay, so let me just see, there are a lot of data sets here. These are public data set. You can access the public data set. I will tell again how to access. Just click on this add data, and here you can see the public data set. Click on this public data set, and it will just take you to the, here you can just click on any of the public data set, and it will just open the public data set for you. Okay, so this is how you can access the public data set. I'll just close this, or I already mentioned in the previous video how to access the public data set. I just want to go to the Stack Overflow dataset, I'll just scroll down again. Yeah, so Stack Overflow. You can see the Stack Overflow dataset here, and I will pick questions table. Yeah, so this is the questions table. So why I'm picking this tables, because it is having almost 23 million records, okay, 37 GB of data, okay, and it is not partitioned. So how you will understand the table is partitioned or not? So you will easily see. Let me check any other table. So it will show it is partitioned or not within the table itself. In the table details it will show if it is partitioned or not. So here it is not showing, it means it is not partitioned. I will show you how it will show once it is partitioned table. Okay, just ignore other tables for now. We'll just focus here on the post questions. And what I will do, I will create one table using this table in my dataset, because I cannot edit this public dataset, right? So I would be having one. Okay, I am having one demo dataset here. So I'll be using this demo dataset, and I'll create one more table here. Okay, so how to create a table from existing table? So first thing, copy this, or you can simply click on query, so you will get the table URL. So this is the complete table URL, but I don't want to take all 20 million records. Okay, so I'll just take few records. So let's try to see how much record it is having. So count. Okay, so I'll just see how much record it is having. So we already saw it is having the 23 million records. Okay, I will just try to take half of the records. So let's say, I will get the record based on the creation date. So this table is having creation date. Okay, so I will take the record maybe for the last few years. Yeah, creation date. Let's say what is the max date and min date here. So how old data it is having. So I will just get min creation date. Okay, so it will show us the oldest data. Okay, so it is having data from 2008, and what is the max? 2022. Okay, that is fine. So what I will do, I will try to get the data after 2017. So it would be few million columns. Let's try to see. I will just check a count of star. Okay, so I will just do count of star here, and I will take the date after 2017. Okay, so I will just add where clause, where date of. So here we have to give the column name. So column name is creation. So why I'm giving the date of, because this is the date time column. From date time column I have to get only date. Okay, and it should be greater than 2017-01. So what I'm doing, I'm just getting the records which are greater than 2017. So let's see how many are there. 10 million records. I think this should be fine for our demo. So I will just create table. Okay, so how to create table from these records? I will just write select star here now. Okay, and I will create my own table. How to create? So simply create table, and format should be my project name, that is ttdev 002, my dataset name. So we finalized our dataset already, right? So let's come to top. We have dataset. Just take demo. Okay, so I will choose the demo dataset, demo dot, and I will give the name as a stack. Okay, stack overflow underscore QUE. Just for question I am giving QUE. Okay, or just write complete thing. I will just write stack underscore question. Okay, So this is my table name, create table, and I will just write as. Okay, so what will happen? So whatever the data available in this query will be created along with this new table. Just create this one. It will take few seconds because this is our 10 million records. Not found project tt dev 002. I think it's only 02, not 002. Run again. Yeah, so it will take some time, and within few seconds it will create our new table. Then we don't need a public data set. Okay, so it created. So let's see. So this is our new table with the 10 million records. You can see 10 million records, and it is having almost 10.75 GB, means 19 GB of data. So that is the huge data. So let me try to just write a simple query. So again, as we discussed, it is a columnar data set. So even if I am fetching one record with the select star, it will cost me for complete 10.75 GB. Okay, because this is the columnar data set. But to improve this, we can use a partition. Okay, so just take one simple query. Okay, so just try to write, because this table is having what columns it is having. Preview. So it is having creation date, and then it is having what columns it is having. We'll just try to filter some data because these are the 10 million. Yeah, tag. So we'll try to get the tags. We'll use, let's say, Android tags. So what I will do now, I will just fetch the data for the creation date. Okay, I will try to fetch the data. I'll just select star, and I will add some filter condition. Let's say I want to fetch the data where uh, creation date between, and I will take only maybe last 6 months of data, 2021 0101 and 2021 0601. So what I am doing, I am just getting the data from 1st June to the 1st Jan to 1st June, 6 months of data, and with the tags, and I will take the data for tags is equal to Android. Okay, so this is the simple query I'm writing. Spelling mistake. Yeah. So you can see this is one liner query, and how much record it will. So it is again scan complete table. So it is 18.75 GB of data. So let's try to see here. Let's try to execute this query. So we can format the query. Just do format query, and this is formatted. So I'll just execute this and see how many records we will see. Okay, so this only fetch 737 records. Okay. Okay, now see the performance, because this table is not partitioned nor clustered. Okay, where we can see the performance, go to execution detail. Okay, so here you can get the slot time consumed. So your billing will be on this slot also. Okay, so we will see the slot consume time. So it took 1 minute 42 seconds. I will just note it down. Okay, so this is for the not partition, not clustered table. So slot timing is, how much is slot timing? 1 millisecond 42 seconds. And how much data is billed? So here you can see how much bytes billed, means cost for your build. Okay, so this is your build byte, 10.75. Okay, so I will just paste this also. So you are paying for 10 GB for this query. Okay, and this we already got here, or let's take in milliseconds. Okay, so the slot millisecond is this much, 10,000. I think 1 lakh 2000. Okay, this is fine. This is a millisecond. Now what I will do, I will create a partition table. So I will go back here. So how to create partition table? So you cannot add partition on existing table. You have to create a new table. So here only I will use the same query. I will just change a little bit. Okay, so how I will change it? So in the same query I will just write, so I am, while creating the table, I'll just write a partition by. Okay, it will just auto suggest partition by. If you're not auto suggesting, just type control space, it will auto suggest. And then I will give the column date of. Okay, so you can give date of. So which columns we want to partition? We want to partition on the creation date. So I will just give creation date. So what I am doing now, I'm partitioning my table on the partition date, I mean the creation date. Okay, now I will create a table. So let me execute this query. Okay, now let me change the name because this is already exists. So I will give underscore p for partition. Okay, so I will just give p. So this is a partition table. So it will create new table with new 18 GB data, but it should be partition. Okay, so I'll just execute. So it will create a new table here in this data set, stack questions underscore p. So you can do this demo in free tier. Okay, it will not cost you more. Most of the things are covered in free tier only. So it is taking time because it's creating the partition table. Now I will show you the difference. Okay, so we created, this is a partition table. How you will understand, if you open this table, immediately it will show this is a partition table. And how it is partition? So you can see this is partition on day and column is partition date. Okay, and if you see the first table, you will not see that details. It is not showing partition tables. Okay, and the records are same, no other difference. So you'll see the records are same, 10 million record, 18.75 GB data. Now the real magic starts. Okay, what I will do now, so let's go to our query. Okay, same query I will execute on the partition table, and now let's see the difference in performance. So instead of question, I will write on question underscore p. So again I will show the dry run here. See how much data is using, 18.75 means 19 GB data for the this query, which is the table is not partition, not cluster. Now the same query I am executing on same data, but table is partition. You can see it only scanning 1 GB of data. So your cost is for 18 GB is less. And what about time? We will see the time as well. I'll simply execute this query now, and let's see the time. First see the result. The same amount of result is there, 737. And let's go to job information. You see it scanned only one, like byte builds only for, you will be charged only for 1 GB. I will just get the stat here. Okay, 1 GB, and the millisecond slot millisecond 19 thousands only. It's dropped from 1 lakh to 19 thousands. So if I go to execution detail, earlier it was 1 minute 42 second, now it is only 19 seconds. So this is for partition table. Now you can see our performance also increased and our price also decreased. So that is why we should use a partitioning. If we have the huge tables, it will help in a bigger way to reduce the cost and increase the efficiency of the query. Okay, now this is about the partitioning. What about the clustering? I will just with partition. Okay, now I will create one more table which will have partition as well as cluster. Again, go back to same query. Here I will just modify the query. Okay, I will create one more table which will have partitioning and both cluster. So the partition by will remain same. For the cluster, what we can do, we can just change the table. After that I can write cluster by. So I can cluster by tags now because we have Android tags we are using, right? So I will do cluster by tags, no other change, and I will create, okay, here the name I will change as a PC because this is partition and cluster. So let's create the table. Now this table will have partitions as well as the clusters. The clusters are based on the tags value. It will store the similar tags into the near memory location on the same memory block, so the query becomes faster. And we will see the huge difference from the table, first table to the third table. So let's table get created. Okay, so the PC, let's check the details of the table. So this is partition table. So if we scroll down in details, so it will show the partitions are based on the creation date column and clustered by tags. The data is same. Now let's try to execute the same query again on the third table, and let's see the performance. I will show again here. So this was consuming 18 GB, this was consuming 1.3 GB. Okay, so sometimes clustering have slight increase in performance as well. I mean the decrease in performance as well if you are not using correct column for the clustering. So let's see here for PC column how much data it will scan now. So here 1.32 GB, and let's say for this table, okay, it is same. So on the data side it does not impact much, but let's check the query speed or the performance on the time. Okay, I'll go back to job information. So byte processed, yeah, it reduced. Okay, I think I haven't changed, right? Let's execute this. Okay, yeah, 1.32 GB, and if you see the execution, so 24 seconds. So this is 24 second, and partitioning byte is 1.2 GB, right? So it is now using 1.2 GB build. So definitely cost is again decreased from 1.32 GB. So it is only 1.2 GB now. Query time is a bit different, but it might be because of other issues. Let's try to execute again. It's cache now, it will give the result from cache. Yeah, so maybe we can change something. I'll just change one day. Okay, so it will not give the result from cache. Yeah, you can see it's giving result only in 14 seconds now, and the here we can see the data. Yeah, 1.19 GB, 14026. So again it's only having 14 seconds now. So performance is also increased and cost is also decreased with the partitioning and clustering. So hope you understood now the difference. We checked all these three tables. First is without partitioning and clustering, which took a cost for 10 GB for the same query, and the time it took 1 minute 42 seconds. We check the partition table, the cost is drastically reduced, and then after clustering there is a minor difference. Okay, so you can use a partitioning if required, you can use partitioning and clustering both, but the effect of clustering based on the data you are having. If you are having a good cluster data, you will see the difference in clustering, else partitioning alone will help you to reduce the cost and increase the efficiency of the query. Okay, so hope you understood now how we can use partitioning and clustering and how it help to reduce the cost and improve query performance. So thank you for watching this video, and we'll see the more topics on BigQuery in our further videos in our playlist. So let's see in our next video.